Salam and welcome everyone. So today we're going to be working on the question on the screen that says, suppose that n sub a is equal to 0.22 n sub b and a small change in composition results in mu sub a changing by change in mu sub a equals negative 15 joule per mole. By how much will mu sub b change? So looking at this question, there's a lot of n sub a, mu sub b, um, changing mu sub a and all that. What is just basically telling you is the information that you need in order for you to solve this question. So I'm going to reread this question, but I'm actually going to say what each one of those symbols mean. So you have suppose that n sub a. So basically, suppose the number of moles of component A is 0.22 n sub b, and a small change in composition results in the change in chemical potential changing by negative 15 joule per mole. By how much will the chemical potential of B change? So that is what this is basically telling us. And for those of you who don't know, this is a question from the Atkins Physical Chemistry 11th edition textbook. And this is how you solve questions like this. We've been told the number of moles, we've been told the change in chemical potential of A, and we're asked to solve the change in chemical potential for B. So the number of moles of A, n sub A, we've told that that's just 0.22. Answer B. We don't need to know what the number of moles of B is because we've seen the relationship between the number of moles of A and the number of moles of B. Now we are told the change in chemical potential of A, which is just negative 15 joule per mole. Okay. And then they want us to tell them by how much the change in chemical potential of B is. So that's basically what this is. Now, you've got all these questions that you're working on and everything that you have to deal with. So the main thing that you have to note is that this question is from chapter 5, which is just dealing with simple mixtures from the textbook. And you have to use something called the Gibbs-Duhem or Duhem equation. So the Gibbs-Duhem equation is the equation that just basically explains questions like this. So the Gibbs-Duhem equation is just simply the change in Gibbs energy is equal to N sub A, okay, D mu sub A plus N sub B, D mu sub B equals 0. So what this equation is telling us is that we have to determine the product of the number of moles and the change in chemical potential of each component, and then we're going to add up the product of each one of that information for each component. So in this situation, we have a binary mixture, which is just a mixture between two components. An example is sugar water, which is just basically the mixture of sugar and water. Those are two components. That is an example of a binary mixture. So in component A, we'll multiply the number of moles of component A by its change in chemical potential, and we add that to the product of the number of moles of component B and the change in chemical potential of component B. So all of this is going to equal 0. And it's important for you to note that at constant pressure and temperature, the change in Gibbs energy equals 0. So that's what's going on here. So basically the formula to solve this question is just going to be the number of moles of component A multiplied by the change in chemical potential of component A plus the number of moles of component B multiplied by the change in chemical potential of component B. All of that equals 0. So that's basically what we're going to use to solve this question. And since we already know what we're doing, we just have to simply substitute. We know what n sub A is. N sub A, we know that to be 0.22 n sub B. We know what the change in chemical potential of A is just negative 15 joule per mole, okay? And then what we're looking for is the change in chemical potential of component B. So that's basically what's going on. So 0.22 n sub B, okay, multiplied by negative 15 joule per mole, okay, plus n sub B multiplied by the change in chemical potential of component B. All of this information equals 0. So that's basically what's going on here. So we use our calculator. We have 0.22 n sub B multiplied by negative 15 is just simply going to give us negative 3.3 n sub B, okay, joule per mole is equal to, we're going to move this from this side and put it in the opposite side of the equation. So we end up with negative n sub b multiplied by the change in chemical potential of B. So that's going to what that's going to be. Of course, we divide both sides by the common. Um, we divide both sides by negative n sub b, which is what is common since we're looking for an unknown here. So we divide it by negative n sub b. So we cancel out this one here, cancel out this one here, cancel out this one here, cancel out this one here. So the change in chemical potential of B is just simply going to be positive 3.3 joule per mole. And that is basically the answer to this question. So yeah, that's it. I wish you guys all the very best. If you have any questions, suggestions, or concerns, please put in the comment section. If you're a student who is trying to succeed in physical chemistry as well as other STEM related courses in your high school, middle school, university, or college, make sure you email me at shohabitutoring@gmail.com. I help students succeed and better their lives in academia. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.